There is a common trap in property management. It is the assumption that if a wall looks intact and feels dry to the touch, the water damage event is over. Property managers and insurance adjusters who sign off on a space based solely on this visual inspection are taking on immense financial risk. Water does not stop moving just because the surface evaporated. FLIR, or forward-looking infrared, is a thermal imaging technology that detects minute temperature differences. Under a FLIR lens, we can see how water actually behaves, pooling and wicking aggressively into hidden structural cavities long after the visible leak stops. To accurately mitigate moisture, professionals have to stop guessing with their eyes and start applying building physics and rigid, verifiable protocols. Signing off on a visually dry room is the exact reason a minor plumbing leak reliably mutates into a multi-thousand-dollar mold remediation project 3 months later. This timeline shows the strict biological countdown inside a damp wall cavity. Between hour 48 and hour 72, a simple water intrusion escalates into a severe biological hazard as mold spores begin to multiply exponentially. Pointing a few consumer fans at a wet carpet does nothing to arrest this biological transition happening inside the walls and subflooring. Halting this threat requires adherence to the IICRC S500 and S520 standards. The IICRC, or Institute of Inspection, Cleaning, and Restoration Certification, develops the specific industry-approved protocols for water damage and mold remediation. These guidelines remove subjective opinion from the equation entirely, replacing a contractor's best guess with quantitative, measurable moisture data. Missing that initial 72-hour window to deploy these exact protocols guarantees a standard structural nuisance will become a severe pathogenic liability. Looking at this chart, professional mitigation relies on a calculated matrix. The y-axis measures the pathogenic load, grading the water's contamination level. Category 1 is clean water from a sanitary source, like a supply line. Category 2 is gray water carrying chemical contaminants, like a washing machine overflow. Category 3 is black water, highly pathogenic liquid from sewage backups or floodwaters. This grading is highly sensitive to time. If Category 1 water sits stagnant for 48 hours, bacterial growth escalates it straight into the Category 3 zone. The x-axis measures the physical scale of the problem, the volume of the water, and the difficulty of extracting it. Class 1 represents minimal water absorption, usually affecting a small area of non-porous materials like tile or concrete. Class 3 indicates a high-volume saturation, where large amounts of water have soaked deeply into highly absorbent materials, like a flooded carpeted room. Class 4 is the most severe. This is deep saturation trapped in confined, difficult-to-reach spaces, like water pooling under hardwood flooring or deep inside the chassis of a custom RV. A safe, legal mitigation plan cannot be engineered until both the pathogenic category and the volumetric class are accurately plotted on this matrix. To understand why Class 4 damage is so difficult to treat, we have to look at capillary action, the ability of a liquid to flow in narrow spaces without the assistance of external forces like gravity. Drywall is highly porous. When its base sits in water, it acts exactly like a sponge, wicking the moisture upward into the wall cavity. Behind that drywall, materials like cellulose and fiberglass insulation immediately absorb this incoming moisture. Upon contact with water, these materials instantly compress and lose their thermal resistance, destroying their ability to insulate the building. Because cellulose is made from recycled paper, that wet, compressed mass now serves as an ideal, hidden incubation chamber for mold spores. The wooden base plates supporting the entire wall structure also sit entirely concealed beneath the flooring, quietly soaking up water and rotting out of sight. If this moisture reaches the HVAC system, the ductwork transforms into a distribution network, blasting mold spores into every room of the property. Because these highly reactive materials are buried deep within the building envelope, a standard visual inspection systematically misses the most dangerous reservoirs of moisture. Overcoming the invisibility of capillary action requires technicians to deploy highly specific sensory technology. They use FLIR thermal cameras to detect minute temperature differentials, revealing hidden moisture plumes behind seemingly dry drywall. They follow the cameras with penetrating moisture meters to quantify the exact water content inside the wood, and hygrometers to measure the relative humidity of the trapped air. This data drives a process called water mapping mastery. Technicians start at the point of entry and systematically track and document the physical extent of the moisture outward, inch by inch. This creates a detailed, color-coded diagnostic floor plan, categorizing the severity of saturation from yellow for minor intrusion up to red for severe damage. The resulting map dictates the exact strategic placement, type, and volume of industrial drying equipment needed for the space. This mapped data also provides the absolute bedrock required for accurate Xactimate estimates. Xactimate is the standard software used by the insurance industry to calculate property damage and repair costs. Without a technological water map, any insurance claim or restoration effort is operating entirely blind, leaving the property open to severe, unmitigated liability down the line. Once the map is drawn, technicians execute a strict mechanical remediation sequence defined by the IICRC. Step 1 is containment. Technicians install heavy-duty plastic barriers to seal off the damaged areas, preventing the cross-contamination of mold spores into unaffected zones. Step 2 is rapid extraction. Industrial wet vacs and heavy-duty pumps remove all standing water immediately to halt any further structural saturation. Step 3 applies psychrometric dehumidification. Psychrometrics is the science of the physical and thermodynamic properties of gas-vapor mixtures, in this case, the air and the moisture trapped inside the building. Technicians mathematically monitor airflow to actively force evaporation, physically stripping water vapor molecules out of the porous substrates and pulling them into the dehumidifier intakes. Step 4 requires the mandatory application of professional-grade antimicrobial treatments to neutralize bacteria and inhibit future microbial growth. Finally, any non-salvageable materials, like heavily contaminated Category 3 drywall or ruined insulation, are surgically removed during the tear-out process. True restoration is never passive drying. It is an aggressive, mathematically calculated extraction of moisture and pathogens. We see these exact principles tested at the absolute limit during macro-scale destruction, like this flooded suburban neighborhood submerged in massive volumes of Category 3 floodwater. Massive storm events instantly bypass the minor leaks of Class 1 and 2. In coastal communities like this, the water forces immediate, widespread Class 4 saturation into every confined structural space. When the building envelope fails under these combined water and wind forces, simple drying is no longer an option. The structure requires complete deconstruction. In mass loss events, the sudden lack of available certified professionals compounds the damage, leaving highly pathogenic Category 3 water to sit and fester for weeks. A catastrophic total loss is simply the final physical manifestation of what happens when the principles of moisture mitigation and rapid containment are either overwhelmed by nature or ignored by property owners. This chart illustrates the financial reality of water damage. The liability is strictly exponential. Line A shows what happens without a professional response. The financial cost curves violently upward as the days pass. Delays force complete structural replacement and trigger costly additional living expenses, or ALE, to house displaced occupants. But line B shows an immediate IICRC certified response. The cost rises for the initial mitigation, then flatlines and stabilizes indefinitely. Navigating this threat safely requires a precise understanding of the water category, the material class, and the rapid deployment of thermographic moisture mapping. Relying on uncertified intervention or visual guesswork to save money up front is an unacceptable professional liability that guarantees a higher payout later. True structural integrity and actual peace of mind is only achieved through rigorous adherence to IICRC standards, thermographic data, and an immediate algorithmic response to the physics of water.